So, students, welcome to today's class, where we shall be discussing on the forces acting on the chassis of the vehicle, or the chassis of the vehicle, or the frame of the vehicle. So we have several forces, like the reaction force from the ground acting on the vehicle. Reaction force. Remember in the Newton's law of motion, the land law states that whenever there is action force, there is equal and opposite reaction force. So as this vehicle moves, due to its weight, the weight will apply the force downwards, then there will be a reaction force which will be acting on the wheels or the tires through the suspension to the chassis of the vehicle. We have this the force due to weight, and the component. So you realize that the weight of the vehicle will all act on the chassis of the vehicle. The weight of this vehicle will act on the chassis. So, and the weight will act downwards. The weight will act downwards. We have number 3, the centrifugal force. The centrifugal force. The centrifugal force, this occurs when the vehicle is turning, or when the vehicle is cornering. When the vehicle is cornering, it tends to have what we are calling the centrifugal force, and which act on the CG, or the center of gravity, the center of gravity of the chassis. So we have the other types of force, the bending or torsion. The bending. You realize that if you have a beam, then you round that beam. You round that beam. The moment there we call it the bending moment. So this beam, all the chassis. Remember, the chassis are the beam or the frame of the vehicle. It is being rotated by several components across. So we are saying we have this bending moment in the chassis system. Now we have another force. We call it the impact. The impact. It occurs when the vehicle passes over potholes. You realize that when the vehicle is moving in that roads, there is the rebounds or the impact. It moves on. So impact is caused when the vehicle is moving on the potholes or uneven road. So we have lastly number 6, the aerodynamic forces. The aerodynamic forces, we have several types of aerodynamic forces, like the frontal pressure is an example of aerodynamic force. We have the rear vacuum, another example of aerodynamic force, and lastly we have the boundary layer. The boundary layer is another example of aerodynamic forces. The aerodynamic forces are encountered when the vehicle is moving at high speed. On the same note, we define the term aerodynamic. We say aerodynamic is a branch of physics that deals with the standard of liquid and the gases that are in motion. The standard of liquid and gases that are in motion. So you realize that as the vehicle moves on, it encounters the drag or the air resistance. The air resistance. We have air moving. So that is why we are coming up with to find the aerodynamic in vehicle body works. So we define the term drag. Drag is air resistance. As the vehicle moves on, it is being resisted from motion by the air. So to calculate drag, we are saying drag is air resistance. To calculate drag, this is the formula of calculating the drag. Drag is given by R log V squared A C D, where log is the density in kg per meter cube. We have P is the velocity in meters squared. A is the area. And the C and D is the aerodynamic coefficient. Aerodynamic coefficient. So in our next class, we shall be discussing on the devices used to resist or to overcome the drag. The devices that we use on the vehicle, on our motor vehicle, to reduce the drag, the air resistance. One of it, we shall be talking of the spoiler, the wings. You find the vehicle installed with the wings, and we have the spoiler, the winds, among others. So today we are going to stop at that point, and we continue from there. Thank you.